Hello everyone, my name is Amanda Magstadt and I currently just finished my junior year at Washington State University studying food science. I'd like to thank you all very much for taking the time to be here today. I'm going to be talking a little bit about the research that I've been doing this semester as well as the upcoming Build Dairy project that I'm going to be working on this summer. This semester I've been working over at the University of Idaho at Dr. Joyner's rheology lab. Over the past couple months I've been absorbing as much information as I can regarding all things rheology based. Rheology is the study of the flow of matter involving a time-dependent behavior under the influences of stress. This is typically done in a liquid state, but also as soft solids under conditions where they respond with plastic flow upon an applied force. The types of samples I have been working with so far are hydrocolloids and gums, such as methylcellulose, cellulose gum, agar, and locust bean gum. Hydrocolloids are a hydrophilic polymer, meaning that they are attracted to water and absorb it, turning the powdered substance into a gel. These types of products are generally found in ice cream, yogurt, and jellies. I have been taking these substances and placing them on a rheometer and measuring their shear rate versus shear stress. A rheometer is a machine that measures the rheological properties of a substance, such as the ones I've been testing. The specific machine I've been using is called the Anton-Par MCR702 Twin Drive and is displayed in front of you. This essentially means that there's two motors in the machine, one is found on top and one is on the bottom. My sample gets placed on the center of the bottom plate and gets compressed by the top plate. This then allows me to change the plates to spin in numerous rotation configurations. There are three types of configurations that I have been using to test my samples with, and they are called CR, CMT, and SMT. Starting from the left, we have a visual of what CR looks like. The green line represents torque measurements, and the brown line is the direction the plate is rotating. CR stands for counter rotation, and both motors are rotating and measuring but in opposite directions, creating the counter movement. The middle image is SMT, which stands for separate motor transducer, because the motor that drives the plate in rotation is on the bottom, separate from the one that does the measuring, which is the upper plate. Lastly, we have CMT, which is the combined motor transducer and does both rotating and measuring on the upper plate, while the bottom plate is in a fixed position. Hence, this is why it is called the combined motor, since the upper plate does both jobs. Overall, these two motors within this style of rheometer help give a more accurate reading on data due to the three modes implemented. My summer project that I'll be working on for the next couple of months focuses more on food foams made from dairy proteins and how they break down under shear. I will be actually making the dairy foams and testing them under various conditions and gap settings. I'll continue to learn more about rheology and how it pertains to dairy foams now instead of the gums I have previously been learning about. I'm looking forward to taking the knowledge that I've learned over the last semester and using it this summer to educate myself more. Since I've begun my undergrad research, it has really opened my eyes to the possibility of going on to grad school. I think that through this experience of working hands-on in a lab setting and working with grad students and PhD students, I'm able to kind of see what the next couple years of my life would look like if I chose to go on to grad school. Before working for Dr. Joyner, I'd only had a little basic knowledge of what rheology was, and my interest and excitement for this type of research is only growing from here. I hope this continues through the next couple of months as I work on my dairy foams project. I'd like to thank Dr. Joyner for pushing me as an undergrad to give everything 100% and be confident in my work and learn from my criticism. I'd also like to thank my fellow PhD and grad students in her lab for making me feel welcome these past few months. Thank you all again for being here and listening today.